So next up, we're going to talk about one of my favorite commands in Git, something called Git Reflog. It's not one that's used all that often, but when it is used, at least when I use it, it's when I've screwed something up terribly and I've lost a commit, or I've rebased when I shouldn't have rebased, or I want to undo something that seems undoable. Well, with the help of the git reflog command, often we can fix things. We can dig ourselves out of some pretty bad situations. So I recommend you check this section out. I think it's definitely worth your time. With that said, if all things go well, you won't be using any of what I show you very, very frequently at all. So I'm not going to say anything is critical. This is a sort of concept where you might just Google in a time of need. You might be desperate. How do I fix this? How do I retrieve this commit that I've lost? And if you read some Stack Overflow post, it will tell you the exact git reflog command that you should use. So it's not something you need to commit to memory. Anyway, I'm going to say everything in here is nice to have. I'll put it in important. It's between important and nice to have. Rescuing lost commits with reflog, undoing rebases. The one thing that I'll say really is not that critical. Well, nothing's critical, but that's not as important. There's a video on time-based reflog qualifiers. You'll know it when you see it. It's not as important as this stuff. But anyway, remember, you won't be using this very frequently. If all goes well and you don't make a huge number of mistakes, you won't need to use this command very much. But when you do need it, it really is a lifesaver. Okay, so let's start talking about reflogs. So the term reflogs is short for reference logs. And I recognize it doesn't sound very exciting at all, or even that useful. But trust me, we will see how these come in handy. But they are just logs. They're just a transcript or a record that Git keeps for us of whenever references are updated. So references in Git, I've also used the term pointer, are things like this in my diagrams where I have an arrow. So a branch, every branch has a branch reference, right? That is what keeps the tip of the branch. So in my diagrams, it's been a name with an arrow pointing to a commit. Another reference we've seen would be head. So head can refer to a branch, or it can point to a commit in detached head. There are other references as well, things for remote branches. There's fetch head, merge head. There are different references in Git. So Git is going to keep a record of when they change, and it actually stores them in a file. So in my diagrams here, I'm kind of indicating the potential log for head. So a ref log, a reference log for when head changes. So here's head in this hypothetical situation. It's pointing to feature, which in turn is pointing to this commit. So then we make a new commit H. I'm just using letters to make it simple. But then we switch branches. Head now points to main. So Git actually takes note of that, and it says, oh, you just switched. Head changed from main to feature. Or other way around, I think. It changed to main from feature. And then if we switch back, Git takes note of that. You switched to the feature branch from main. So it has this running log. We haven't seen it yet, but there is a log, and there's actually a file that we can take a look at for head. If we want to see the ref log, the reference log, in any repository, I'm using this React repository because it has a lot of history. If you want to follow along, I would just work on any repo that has commits and branches. And if we look in the .git folder, there is a directory called logs. And I can actually see it over here. I have the .git folder open in VS Code. Here it is, a logs directory. And then there's a file called head. And this might be shocking, but this file is actually readable. It's not compressed, it's not binary. It's a lot of text, but what we have are a series of entries in here. So here's the first one, and the second one, and the third one. I'm pretty zoomed in, so it kind of makes it look worse than it is. But each one of these entries is a move for the head reference. I'll just show you down at the bottom, head, most recently, let's see, there was a new commit made, and before that, I actually did a git reset. Before that, I did a commit, but then before that, I moved from some commit, I was in detached head, and I moved to master. So it's tracking when I switch branches. So instead of just going through a history, you weren't even present for any of this really, why don't I show you what happens when I make changes, when I actually update the head reference live. So I think what I'll do to make this easier is actually put my terminal side by side. Okay, here we are. This will allow me to show you the updates happening live. So this is the same repository. By the way, you should not edit this file. I just accidentally typed something in there. You don't want to edit this directly. These are just logs kept by Git. Okay, so there are many ways to update head. The simplest way is just to switch branches. So let's see what branch I'm on in this repo. I'm on the master branch. Let's switch to the turtle branch, okay? So git switch turtle. And watch right here, we'll have a new entry added into this file. And it says, checkout, moving from master to turtle. So it doesn't say switch, but that's what we did, right? We checked out a branch, we just used the git switch command. So it took a record, or it made a record, just like I showed in this diagram. Git is tracking our moves, or it's tracking the moves of the head reference, rather. So if I do something else, how about I go into detached head? So git log, let's just see what we've got. Let's pick some commit. How about this one right here, 295. If I do a git checkout and I give it a commit hash, we know that that puts us in detached head, and it tells us that. And if I look at the log, it now says, this is where we were. You moved from the master branch to turtle. Well, now it says, hang on, wait a minute. You're at this commit. Checkout, moving from turtle to 295D. And that's exactly where we are. So now if I switch back, let's go back to master this time. We have a new entry. It says, okay, at this time, which I haven't shown you, but there's a timestamp in here. At this time, you moved from this detached head commit to master. You're back on a branch. All right, so we have these files that we normally don't open up and look at. I'm going to show you in the next video. There's a command we use to interact with these files, but Git keeps these records for us. When head changes, that's one example of a reflog, because that's one example of a Git reference. But there are other things in this logs directory. Actually, it keeps track of the tip of every branch. So here's the master reflog. Let me make this larger. The tip of the master branch as it changes. There are fewer entries because it just doesn't change as much. Or the donkey branch, or the turtle branch, or remote branches. So you can see, for example, every time I push up to the Colt remote, the master branch, there's a record of it. It says you updated by pushing, you updated by pushing, you updated by pushing. So that's all that I want to say for now, just with these files, just the fact that they exist. Git is tracking, it's keeping these logs that we can reference later. And this can be a lifesaver at times. If we make mistakes, if we need to access some commit hash that we no longer see in our Git log, I will show some demos of that. But first, I want to talk about the git reflog command. Instead of viewing these files directly, we can use a command to take a peek. So that's coming up. Now, before we go any further, I think in the last video I said I was going to show you this git reflog command, but first I just need to make a very important announcement about reflogs. I made a separate video to tell you this. Reflogs are only local. That's the first bit. So I could be working on a repository with thousands of collaborators, like this React repository. This has thousands of commits from at least, I think, 1,500 different people. I don't have their reflogs. I don't know what happened to their head on a day-to-day or minute-to-minute basis. That would just be absolutely overwhelming. So reflogs are local. Git is only storing, it's only logging my changes to references on my machine locally. And furthermore, they are non-permanent. They do expire. And I think the default, according to the Git docs, is around 90 days, where old entries will be removed. But you can actually change that. But I don't really think it's worth changing. I wouldn't change it, but there is a way to do that. You can make it shorter if you wanted to. But the main takeaway from this video is that they do expire. So it's not a permanent record of everything you've ever done if you have a really old repository with lots of work locally. So again, only local changes are tracked in reflogs, and they do expire. Okay, so now we move on to the git reflog command. So this command works with 4 different subcommands, but the good news for us is we only need to care about one, which is the git reflog show subcommand. The other 3, expire, delete, and exists, are not really used. And when I say that, I'm not just being a lazy teacher who doesn't want to show you. The documentation, if we take a look for git reflog, it actually says exactly that. For example, for expire, it says this is typically not used directly by end users. For delete, something similar. This subcommand is also typically not used directly by end users. The only subcommand they really document and show examples of is show. So I'm not making it up. We really just need to know about show. And the show command or subcommand is pretty straightforward. We pass a reference, head or a branch tip or a remote branch, and then we will see a log. We'll see a printed version of the stored reflog. So I'll show you that. Let's do git reflog show head. We've been looking, or we've seen this head reflog file right here. All these entries. I'm not sure how, maybe 60 something different entries in here. Maybe fewer, 50s. Anyway, if I run this command, git reflog show head, we see a log similar to git log, but it's not the same. Okay? For one, this includes things git log does not include. For example, if you check out a branch, right? Git log doesn't care that you checked out a branch. It doesn't add a new entry. Git log is just a log of a commit and its parents commit and its parents and so on and so forth, on and on, but it doesn't include things like checking out. Also, this is all going to be a history of things, right? So we could delete commits, we could rebase, but we're still going to see entries from when we did that. For example, here I did a reset. This was before I was recording. Actually, I recorded this video a couple times. It was in a previous version of this video that will never see the light of day. So I made a reset, right? And I deleted a commit. But the thing is, that commit was actually right here. So this is that commit that I deleted. And the crazy part is I still have that hash. In git log, that hash is completely gone because I did a reset. Anyway, we'll talk more about the differences in the utility of reflogs, but I hope it's clear that there's a difference. This is keeping every single thing, assuming it's been less than 90 days and it's all local, it's keeping track of every change to head. Git log is just going to show me a lot more in this case in terms of the number of lines, but it's only going to show me a clear history from one commit to its parent and so on. So there's stuff that I've done that I may have lost, I may have deleted, I may have reset and rebased. I don't have record of that on git log, but I may have record in my reflog. Anyway, we see starting from the very beginning up here, the first line is actually the most recent change, the most recent entry in the head reflog. And then down here is the oldest thing. So I first cloned this repository. And so head, when I cloned, was pointing to this commit. So we can see the commits that I was referring to over time for head, right? So currently head is pointing to this, it's pointing to master, but master is right here, D83. But also we can see, what happened. So in this case, I moved from a commit, detached head, back to the master branch. And then I moved from, before that, I moved from the turtle branch to detached head, right? So this is what I did one move ago. I went to detached head, and then here, most recently, I left and I went back to master. You'll also see this notation, head at curly braces, a number. So this syntax refers to a particular entry in a reflog. So the most recent entry is head at 0, and in my case, head at 56 is the very last thing, the oldest thing in the reflog for head. So this syntax can be very useful because we can actually pass this around and reference this reflog entry syntax. We can pass that to other commands. And there's fancier things we'll get to. I'll show you in a little bit. But yes, each one of those lines has its own reflog identifier. But they are relative. So this was the very first thing that happened to head. I cloned. And so right now it's 56. And head 0 is checking out when I move from detached head to master. But if I make a new move, right, if I switch to the donkey branch I have, and if I look at that reflog again, now head 0 is something different, right? This is the most recent thing. This used to be head 0, but now it's not. And at the bottom, we now have head 57. So the point is that these change, right? These are not set in stone, these numbers. And each one of these, each number, is used to indicate a particular entry in the reflog, in this case for head. But we're not limited to looking at the head reflogs. For example, I can pass some other reference that we want to look at. Let's see, the donkey branch. Is there anything that's happened here? Two things. I first made the donkey branch. That was the commit we were on. And then I made my first commit. So unlike the head reference, right? The head reference is updated when I switch branches, when I make commits. There's a bunch of things that change head. But here, this is just showing us the donkey tip of the donkey branch, and that only changes when the donkey branch itself is updated. So switching branches doesn't do anything. But if I make a new commit, we'll see a new entry. Echo haha. We'll put that in a file called haha.txt. We'll add that. We'll commit. I'm just making a commit. Add haha. Okay. So we have this new commit. If I do a git log, we'll see a new commit on the donkey branch 7c1. So that means donkey, that branch reference, was updated. The tip moved. So if I do a git reflog show donkey, now we have 3 entries. We added this new commit, so that is the most recent change, the most recent entry in the reflog. And notice the syntax is the same here. We have a reference name, so it's not head, it's donkey now, but the same principle, at, and then some entry number. So this is something we'll come back to in the next video. There are other qualifiers we can pass in, but the basic syntax is the same. This is a way of referring to a particular entry in the donkey reflog. Okay, so I'll stop this video here. We'll talk more about this syntax and some fancy things that we can do with reflogs up next. Okay, so recall this syntax we've seen, where we have the name of a reference, an @ sign, curly braces, and then some number, so far at least. We'll stick with the numbers in this video. This is a way of referencing, let me use a different term. This is the way of talking about an entry in a reflog for some reference. So in other words, head at 2 is the same as saying where head was 2 moves ago. And we can pass these references around to different commands. So one simple one I can show you is actually git reflog itself. I don't really do this, but I can pass on, instead of just saying everything in the head reflog, I could say head at, and then how about 10? And this will give me everything from the very beginning of the repo, so head at 58, all the way to head at 10, so 10 moves ago. I don't really know why I would do that, but you can. But we can also do things like, let's say I want to know what head looked like 2 moves ago. Well, I can do a checkout. I can do git checkout head at 2 moves ago. Now this is different than this right here. We've seen this. This means the parent of head and then its parent, 2 generations of parents ago. So basically the grandparent commit. But if I do head at 2, this may not even be commits that we are, or parent commits that we're going back in time. We may be on the same exact commit and we just switch branches, because head at 2 is just saying 2 moves ago in the reflog for head. So that might just be changing branches. It might be detached head. Who knows? And we could look it up. But this is what we're saying. Go back 2 entries ago for head. And we go into detached head because we use git checkout. And it says it took us to this commit, D8363. So I'm going to switch out. Nope, I can't have that 0. There we are. Let's do a git log 1 line. So if I did git checkout head tilde2, this is head, this is tilde1, that's tilde2. I go to FFE, okay? That would be going back, right? 2 commits, a parent and a parent. So that is what this syntax would be, tilde2. But again, if I do git reflog show head, if we look at what head 2 ago is, it's this commit, 7c1. That is actually the same commit we're currently on, because there's just an entry in the middle where we went to detached head, we came back, we switched branches. So it may not seem useful like this, right? Why would I want to go back to the same place where I am? I'm on this commit now, and I was on it 2 heads ago. Why would I go back to that? But in the next video, I will show you that we can actually do fancier things. Instead of just saying, 2 moves ago, I could say last week or yesterday or an hour ago. But also, this works with things other than head. Any of these references, we can specify an entry in a reflog using the same syntax. So master branch at 5 is 5 tips of the master branch ago. And we can pass these to other commands too. For example, diff. If I wanted to know, what's changed between head right now and head 5 moves ago, I could do git diff head right now would be 0, and then head at, let's do 5. And I have to spell diff correctly with 2 F's. And there we are, we can see what's changed. Now, if I did this with head 0 and head 2, nothing changed because they're referring to the same commit, just 2 different things over that span. Again, I'll just recap one last time. Git reflog show head. This is head 0, I'm on 7C1, and head 2, I'm on the same commit. Just in between, first I moved from donkey to detached head, and then I moved from that detached head back to donkey. So the end result is the same. Okay, so this syntax will come up in the next video when I show you some fancier options, and it will definitely be important when we see how we can use reflogs to rescue ourselves from potentially bad situations, how we can access information that we might view as lost otherwise. Anyway, next up, we'll see these fancy timed references. Okay, so now on to something a bit more interesting, hopefully. Every single reflog entry has a timestamp associated with it. If we take a look at one of them, here's the head reflog for this React repo. Every entry has a commit hash, right? It has the user who made it, but it also has a timestamp in here. So this is a timestamp, and this includes, the date and the time that the head reference was updated. It's a Unix timestamp. Anyway, we can use this, or rather, Git can use it for us, if we pass through some of these nifty timed reference qualifiers. So instead of saying head at 5 moves ago, I can say head at 1 day ago, or master branch 2 days ago, or a week ago, or yesterday, or I can even provide a fully fleshed out timestamp in different formats if I want to know at an exact time what did X branch look like. But remember, this does not go back more than typically 90 days, but also it only includes local changes. So it doesn't matter what somebody else has done, and what their head looked like over the last 90 days. It's just reflogs on your machine that are just a log of your local changes and movements. Okay, so I can use this syntax in place of, and it's the same syntax, what we've seen here, where qualifier is just a timed qualifier, and this definitely can be useful. Sometimes, if I want to just compare what something looked like, let's just take the master branch right now, today, compared to what it was yesterday. I could go through the Git log, and I could format it so that it also includes commit timestamps, and I could try and figure out which commit was 2 days ago, or what I said yesterday, which commit I made yesterday, and then I could do a diff between now and that, or I could just do git diff between head and then head yesterday, so at yesterday. And this is what's changed between now and yesterday on the master branch. Although actually, this is between head and head. That's probably not that useful. I would do this between the current master branch and the master branch tip yesterday. And there we go. Less has changed. Comparing between head and head yesterday, who knows what branch we're on that's going to impact it, and who knows what branch we were on yesterday at that point in time. So we can also do things like, if I do git reflog show, so I could filter, what I look at in the reflog instead of all entries. For head, I can look at, everything up until 2 days ago. So I can do 2.days ago. And it includes the time for me now. So it shows today's the 21st of February. Here's February 19th. So it also includes all the earlier stuff up until 2 days ago. I believe you can do 2 days TWO, or I know you can. So you can write that out. I can also do things like, 1 hour ago. I don't think I have anything. How about 1 minute ago? Okay. So now we see, it's actually the 22nd, I guess. But anyway, we see that we have the time included here, and what time is it now? 11:21. So this is the closest thing that it can go up to. That's probably all I'll show here. We have these different options: yesterday, multiple minutes ago, hours ago, days ago. You can do weeks ago. I believe you can even do months ago. I don't know if anything will show up for me. 1 month ago. Yeah, it's just empty, but we don't get an invalid syntax. It tells us head reflog only goes back to this date. So this means if I wanted to go back and take a look at the master branch a week ago, when things were working, I know they were working a week ago, one option would just be git checkout master at, and then 1.week ago. So I don't have to find the commit hash. This is just going to take me back to the closest matching reflog entry. Every entry in the reflog, every time that master tip changes, we get a new entry with a timestamp. And now, of course, that puts me in detached head. And if we look at this git log, here we are. Actually, why don't I do just regular git log? This was Friday, February 12th, so the closest thing that happened to that master tip a week ago. And here's that commit hash, right? But I am in detached head, so I can get out of here. But that's one way we can use that. Now what I'm going to show you next is how we can really use this stuff if we make mistakes, how we can undo or retrieve seemingly lost commits and information, and that's coming up next. But in this video, we saw that we can use this pattern to reference a particular entry in a reflog, but instead of just passing a number, like 1 or 5, we can pass in these weird but very nifty timed references because every entry in the reflog also contains a timestamp associated with it. Okay, so next up, I want to show you how we can turn to the reflogs in times of need. In this example video, I'll show you how we could reset, do a hard reset, and lose some commits, but we can still retrieve the data from the reflog. So let's make a simple situation. I was working in that React repo. It just had so many files and commits. It's a little bit more confusing to take a look at. So I'm going to do something simple. You can follow along. I'm not in a repo. I'm going to init, and I'm going to just track the seeds that I've planted in my garden or something like that. So why don't I make a file? I'll call this one veggies.txt. Okay, and I'll add that file, git add veggies, git commit -m add veggies file. I'm just going to build up like 2 or 3 commits. So I open this in my editor. I'll do code dot from my terminal. That's just the shortcut. And I don't have any files except for veggies. So what should I put in here? Well, I have been planting some things recently, so I'll just put some of the stuff I started. We have broccoli and rainbow chard, and what else did I plant recently? Some kale, boring. All right, so now I'll add my first commit, git commit -m. I'll do am, so I don't have to add that file again. And I'll do a commit message like plant winter veggies. Okay, and then I don't know, some other stuff. How about cabbage and some lettuce maybe? Arugula. Did I spell that right? Arugula? No, I think it's like that. So then I'll commit, git commit -am, add more greens. Okay, and then we're going to do a last commit. Let's say I get ahead of myself and I'm just daydreaming about when I can actually start watermelon. It's the middle of winter right now, so not a good time for that. And pumpkins and what's another summery thing that I grow? Well, squash. Okay, so if these are things that I'm looking forward to growing, I get ahead of myself, I add and commit them. So git commit -am, add summer veggies / fruits. I guess it's not just veggies, summer seeds. Okay. Then I decide, oh, you idiots, you can't plant those right now. It's the dead of winter. Get that off of your list. So this is all very silly, obviously. But imagine I've done a lot of work on some project. I want to get rid of that commit. We've seen how to do this. You may have forgotten because it is something that doesn't come up all that often. But to completely undo a commit, we pick some point that we want to go back to. So let's do git log 1 line. And let's go back to this point. So we'll take that commit hash, and then we can do a git reset hard. So -- hard with that commit hash. And the hard will undo the changes in my working directory as well. So we get rid of the commit. And then also, in this case, just one commit. We're resetting back to the prior commit, but we also lose the work that we had in our working directory. And so it's gone there, right? If I type git log, that commit is gone. So if I realize, oh, you can still start them. You have a greenhouse. I wish I did. I don't have a greenhouse, but I turn one of my bedrooms into a greenhouse. If I wanted those changes back, I want that commit. It's not here, right? It's not on another branch or anything like that. It's just not here. Git log one line. Nope, I don't have that. But thankfully, that information is actually still available in the reflog. So if I do git reflog, I'll just do show master, or I could do head if I wanted, but master will work for us, right? Because I'm on the master branch by default. Here is where we were, right? This is where that commit was. There's that commit hash, FB5072A. So we have access to that hash. And here's the information. This is when I made that commit, add summer seeds. This was one tip ago of the master branch. So master at 1 is one way I could access that. I also have access to the commit hash. I could check it out, for example. So if I get out of here, I could do a git checkout and paste that hash in. But remember, I didn't see this in git log. That does put me in detached head, of course, but here it is. I see it. So that puts me in detached head. I'll just switch out of there. And I'll go back to the reflog. It's still there, right? It's just not part of my main git log. This is the history stemming from the commit, this commit right here, going back to its parent and to its parent. The summer seeds commit is just long gone, but Git still stores that information in the .git folder. It will go through and every so often remove commits that are dangling that aren't actually connected. So that commit, that the summer seeds commit, is not attached to anything, right? It doesn't have a parent. It doesn't have child commits. It's just on its own in terms of the objects directory. It's just an entry in there. But because the reflog still references it, we can go and restore back to it. So we just checked it out and went into detached head. But if I want to go back, I want to make this the actual new head of my master branch. In other words, I want to undo the fact that I removed that commit, that I reset. I can use the commit hash, or I can just do master at 1. If I prefer, I can reference it this way. These will be referring to the same thing for now, okay? I can do another git reset hard master at 1, or I could pass in the commit hash that we found in the reflog. And that now says the new tip of this master branch is whatever master at 1 is from the reflogs. And if we do a git log here, we see that we have that commit message back and we have that hash back. So it was gone, right? We didn't see it at all in the git log, but because we had the reflog available, we could go back and find that commit hash or just find the correct line, master at 1, and we could reset based upon that. So even though it looked like we lost the commit, it wasn't tied to any other commits. It was floating on its own. We were able to rescue it. And that can be extremely useful. We just undid a hard reset. But remember, this only works with local changes. Reflogs only exist for stuff you've done on your machine, and they do expire. In the next final video on reflogs, I'll show you how we could also undo a rebase or retrieve commits that we have completely rewritten using Git rebase. Okay, so next up, I want to show another example of how reflogs can help save lost commits or seemingly lost commits. This time I'm going to perform a rebase, which when I first taught it, I made it very clear that rebasing rewrites commits. It makes new commits, and those old ones are gone. At least they seem to be gone until we talked about reflogs. So let me show you an example. Let's make a branch here. I'm working in the same vegetables, seeds, little demo. Let's do a switch. How about flowers? So we'll pretend I'm working on a feature branch, the flowers feature branch, where I will be, I don't know, this is veggies. I'll be working on the different flowers that I want to plant or that I'm starting in my garage or something like that. So what should I put in here? Why don't we just make our first commit? Git add flowers. We'll do a git commit -m, add flowers file. So I'm pretending this is a feature, so I'll have a couple of commits. Let's see, I'll add some flowers. How about some salmon zinnias? And what are some other queen lime zinnias? Okay, so I'll do a git commit -am just to speed it up. Add some zinnias. And then on the next line, what's another type of flower that I grow? How about some dahlias? So we've got old rose dahlia. And there's another, I'll just dinner plate dahlias. I don't even know if that's really a specific one. Okay, so I'll do a git commit -am. I'm just gonna add one more commit after this one. Add dahlias to flowers list. And then how about some amaranth? So coral, fountain, amaranth, and also hot biscuits, amaranth. Git commit -am, add amaranth to flowers. Okay, I lied. I'll do one last one. I'll add some celosia. Some really cool flowers, by the way. These celosias, coral reef celosia. I'll just leave it at that. Git commit -am, add celosia. Okay, so I'm done with my feature. This is my feature. It's not exciting, but I have, 4 commits or so on this flowers branch. I want to eventually merge them into master, but before I do that, I'm going to rebase. I'm going to do an interactive rebase to get rid of some of these commits or combine them or just, clean up. If you did not watch the section on rebasing and specifically the portion about interactive rebasing, this may not, I can't imagine it would make any sense. So I would check that out. The point is more so going to be about fixing it after the fact. So I'm going to do a git rebase back to here. So an interactive rebase. So this is head 1, 2, 3, 4. So I'll do head ~4, git rebase -I head ~4. And there we are. You can see it opens up this file for me to do my interactive rebasing in. But let's say that I want to, I don't know, we'll fix up these 2 or maybe these 3. So that will, if you don't remember, you can see down here, fix up, we'll squash them, basically mush them into the next previous commit, but it's going to discard the log message as well. So if I replace pick with instead f or fix up, and I can do this for multiple, fix up, can do it for all of them. I'll do these 3. So fix up, fix up, fix up. What you'll see is that the contents, the actual changes in the commits don't go away, right? We don't lose that work, but we will be rewriting history. So I am squashing them. I'm melding all of these down into this commit. And so I'm going to save and close this window. And it tells us successfully rebased and updated. Let's look at our git log. And now we have this one commit here. It has a new hash. We rewrote history. And I could repeat the process one more time as well. I won't go back that far, but how about head ~2? And maybe I decide I want to fix up this one. I want to mush it back into this one. And then instead of doing a pick here, maybe I want to reword the commit message instead of add flowers file. So I can do that. I'll rename this, or not rename it, but come up with a new commit message and then mush this one into it. And now it opens up, when I closed out of that window, it opens up the commit message that I can edit. So instead of saying add flowers file, let's go with add flowers, flowers feature. Or how about just add flowers, add list of seeds. Okay, so I'm basically taking all that work I did and combining it into one new commit with a new message. We talked about this with interactive rebasing. We can clean up our history. So if this is my feature, it's simple, but this is the commit. I'll X out of there. And now if I do a git log, we just have this one commit hash right there. And this contains everything for the flowers branch. So If I decided that was a big mistake, or for whatever reason, I want to access those individual commits, I even want the commit messages, or I don't know, I want something from the past, we don't have to fear. We can use reflogs. Reflogs are here. So git reflog show, and then we can do it for flowers. And take a look. Every single one of those commits is still here. Every commit hash. So this is when I added the flowers file. Here's where I did some zinnias, some dahlias, amaranth, celosia. They're all here. So I have to decide, what point I want to go back to. But if I want to go to this point, I want all of those prior commits, all 5 commits that are gone now. I can copy this commit hash, or I could copy this, but I'll copy the commit hash. The commit is still stored in the .git directory and the objects directory. Now, it won't be there forever, but it's definitely there now. Git goes through periodically, as we talked about, and it cleans up some of these, it does this thing called garbage collection if it notices Git objects that are not reachable. So, for example, this is not reachable from another commit that is part of our history. It's stored in there, and so we can basically say, Git, I want you now to point your branch to this commit instead. And this commit was on its own, totally alone, not connected, and now, after I reset back to this commit, it will be hooked back into the grid. We'll have a pointer for our branch referencing to this. All right, so if this is what I want, I can copy this. But just remember, these commits are not part of my history anymore, right? I don't see any of those commits. Just do one line. None of them are here. The hashes aren't here, the messages aren't here, because I fixed them up. I merged them all together and gave them a new message too. I boiled it down to this one commit. So if I want to reset back to that, I can do that. Git reset -- hard, not heard, and then pass in that commit hash. And this says the flower branch, that reference should now point to this commit that we found in the garbage, we found in the reflog. And it says head is now at add celosia. Well, let's look at git log. Hey, look at that. We have all of those commits. And the reason this works is that every commit has inside of it, in that file, it also stores its parent or parents. So if we reset based on this one commit, we also get the parent commit and its parent and so on. So this ends up doing exactly what I was trying to show you. We rebased, we rewrote history, we eliminated these commits, we combined them, we renamed them, or redid their messages, we smushed them together. They were lost, or apparently lost. But I was able to rescue it for whatever reason I decided I wanted to. I'm able to go back and undo that. That rebase it's basically like it never happened. But actually, in our reflog, we can see that if for whatever reason I wanted to go back and undo the undoing, I could. I could go to this commit hash right here. This does not exist right now in my history, but it's in the reflog. So that object is still stored in Git, but we don't see AB9 when I do git log. But I could reset to that, but I won't. All right, so I hope now you can see some of the utility in the reflog. Remember, it's local and it's not permanent, but in a lot of situations, especially if you do something that seems permanent or seems bad, rebasing or resetting, a hard reset, those still can be undone if you know how to look in the reflog.